I've always been enamored with the idea of having a busy light, a status light, something that tells people, you know, like I'm in a meeting, or maybe do other things, like I got a meeting coming up, or like a birthday coming up, maybe. Anyway, the idea is you always kind of want this notion of a presence indicator or something else, and this Neo Trinkey, wow, I've been calling it the Trinkey Neo. Man, oh well, I hope they don't mind. Anyway, it's basically got 4 NeoPixels on it, and you can control it, but it's a microcontroller, and so that means you got to write firmware for it. And I did a demo using Belay before that showed how you could do that without downloading any code. But this time, I'm going to build a command line parser. Basically, it lets you send commands to create patterns on this thing. And it's down here in the corner. You can see it, but it's dark right now while we think about how to do this. So this is in the Trinkey sandbox. Man, I really gonna have to figure out whether I'm gonna, you know what, it's fine. So in here, I'm gonna be sitting it, so this sandbox thing, just, you know, it's got a couple other programs, capacitive touch, that kind of thing. So I wanted to do an indicator light. And if you look in the help here, it basically just a main.py, you drop it on the board along with the logging package and you're good to go. And what I really wanted to do, like I said, was a presence indicator. So and really, it was to do things like plug into Busy Light or some of these other tools that let you plug in different lights into a library. So I actually have this on a branch. It hasn't been merged because it's not a COTS product. And so the owner of this really would rather do COTS things where you don't have to load your own firmware. But you can get this branch. Anyway, like, what's the cool part of this? Okay, so basically, it's got a command. There you go. So it's got a command parser for this, so you can ask it for help. It'll tell you what the commands are, and you can send it a command. There's 4 LEDs. It actually supports up to 8, the software. And the idea is that you can give it patterns, so you can do super basic things, right? Like the pattern is what LED in a bit mask, red, green, blue, and how long you want it to run, and you can send an arbitrary number of these basically, you know, which LED is it going to be? And so let's just pick an example here. So if I pick this one, FF means turn them all on. So I got 4 here, so we'll just try that. If I just paste that in and hit enter, you can see they all turn blue, and that's because it's all LEDs with a little bit of red, a little bit of green, and a lot of blue by comparison, and the frickin' pixels are bright. Okay, anyway, so in this case, I've got 2 patterns, 2 pound signs, doing all the LEDs, 2 different patterns. The default is going to be 100 milliseconds or something close to it if you don't put a time, and that's the dash part. So you can see here it flickers between the 2, right? And so that's a blue and a red, right? And the, well, blue and a kind of a white, really, with a little bit of blue tint to it. Anyway, red and a little bit of blue with white with a little bit of blue tint. So you can also make these, this one would be all the LEDs for 400 milliseconds or close in this pattern, and then for 1,000 milliseconds in the next pattern. So you can see how that works. And so you can see here that one of the colors is a lot shorter than the other, and then we can blank that out. And then this one is kind of the one I've really been playing with. So this is like a 4 LED pattern, and it will just cycle through these. Red, first one, second one, next 2, and then off, right? So this one here is a blanking in the front, right? All the LEDs with 0 color for 10 milliseconds, so it's a really short blanking. And then you see the next one here, and then the next one here, and then the next one here. So it's actually got a few different patterns in it, right? 1, 2, 3, off. And you know that it's 3 here, so this is a bit masked version of this. 0C means control. 2 of the LEDs, the top 2. So anyway, so you can do any kind of arbitrary number. If you give it some bad values, it'll give you an error back. And if you do it right, it won't. If you get, I can just, right? So blanket. Let me copy this. It should fail. Why did it not do that? That's what happens when you don't know, you don't use the copy button correctly. You know what? That's the way it goes. We're not going to worry about it. So, you know what? Let's try. Pound, FF, 00, green, 20. Make it 30 because I typed it wrong. And then we'll do, and that's going to be an error. Oh, nope, that actually worked. So that made it blue, red, green, blue. Why did it do that? Pound FF0003. Oh, I know why. Do I know why? That's really blue. Pound FF000303. And oh, that's a green and a blue together, right? So it's kind of got that green-blue color. Anyway, that's it. Way too long. The whole point of this is if you go back and you to this Busy Light project, not the Busy Light project, this CircuitPython, you can just copy this thing, copy the main.py down onto the CircuitPy drive, and boom, you've got this thing. You can open up a command line to it. That means you can write Python programs. You can do whatever you want to talk to that thing, and you saw that I did it in a terminal, but I could just write regular Python programs for it too. There's a bunch of samples in here. Go play with it. It actually is kind of almost feels like what this thing was intended for. Bye. And just quick freebie. I said I was gone, but nope. So in this case, it turns out a bunch of the Adafruit boards actually have a board.NeoPixel on it. So they have a one wire red, green, blue. So it turns out this ESP32C, S2 actually has this. And I got it plugged into another COM port. And I should be able to just, we're going to pick the COM19. And then we're going to connect to it. Yep. And then we're going to paste it. That actually worked? Yeah, it made it blue, right? And then I can also do a pattern on it. Let's try this. This is a pattern we did before. Yep, so that one's flickering between two. All I really wanted to show is this thing just, you could use some code like this and plug it into any of the Adafruit boards with CircuitPython that have an onboard NeoPixel. And the cool thing on the Trinkey, of course, is it's got some really big NeoPixels, and so it looks great.